Hello, welcome to Chill Phil Gaming, the more calming gaming channel. Thanks for joining me, Phil, and my dog, Hash Brown. He's very chill, as he is in almost every video. He's really good at being calm. I learn a lot from him about how I need to calm down, find comfy things. He loves soft blankets. I love soft hoodies. I also love blankets. And so we kind of go calm, though we are today talking about the first planetary defense experiment that Earth did, even though that doesn't sound very calm, but we look at things in the game Universe Sandbox, which is a lot of fun and really interesting stuff. We can learn a lot from that about our solar system and about what Earth is doing. We're going to talk about what Earth is doing in preparation for maybe some unfortunate circumstances that may arise in the future. And that's what we're doing today. We're going to look at what's called DART. Don't know what that is? Keep watching. Here we go. So in this simulation, DART, humanity's first planetary defense experiment. Very interesting. So DART stands for Double Asteroid Redirection Test. And on September 26, 2022, NASA's DART successfully demonstrated humanity's ability to protect Earth from future asteroid impacts by colliding with Dimorphos. Dimorphos is a moonlet of the near-Earth asteroid Didymus. Okay, so Didymus is an asteroid not too far from Earth, and Dimorphos is a moonlet. So Didymus isn't big, so that, Dimorphos is very small, and it is considered a moonlet. So basically a satellite of Didymus. It is in orbit around Didymus, as we see here on the screen. Here's Didymus, here's Dimorphos, and here is DART. So let's actually zoom in on DART real fast here. Okay, so DART. There's DART. Aw, your DART's cute. DART is cute. Sorry, DART. You're not going to be around for much longer. DART impacted Dimorphos head-on at 6.1 kilometers a second, releasing about the same energy as 2.5 tons of TNT and ejecting tons of dust and rock from Dimorphos. Okay, the resulting momentum transfer shortened Dimorphos' orbit around Didymus by 32 minutes. Okay, so that the goal was to change and shorten its orbit to slow it down for just a little bit by 32 minutes. So first of all, 2.5 tons. Like, how big is 2.5 tons? Let's look that up here.
A few minutes later.
Let's bring this over. How destructive, so this is what came up. How destructive is 1 ton of TNT, okay? So explosion of 1 ton of TNT releases about this amount of energy. In comparison, it takes this amount of energy to warm up a cup of coffee. So I'm guessing that these two are pretty close in energy. I don't know, but why else would they be comparing them? So that's not much. That's not a lot of energy. The radius of 1 ton, 3 tons, and 10 tons was this, and this respectively. So 1 ton of TNT creates almost not even a meter of radius. Okay, so that's not very big. So 1 ton of explosive actually isn't that much. 2.5 tons, which is what we see here, is not much, but the result was momentum transfer shortening the orbit by around 32 minutes. That feels big for 2.5 tons of TNT. So that feels like a good result. Okay, so let's check this out. Colliding with Dimorphos. Let's click this and see what it brings up. Oh, this is cool. Oh, guys, look. So this is, okay, let's read here. The final 5.5 minutes of images leading up to DART spacecraft's intentional collision with asteroid Dimorphos. These are the pictures strung together, 5.5 minutes of images from DART. So if we keep this playing, then we are looking at it in first-person view from DART. It's taking pictures, and they've strung it together in this and put it together in this video. So that's Didymus, and here's Dimorphos, and here we come in to Dimorphos, and we're gonna hit it. We're gonna hit it. There's no slowing down here. Oh, okay. There's some slowing down of images. It's processing or something. Boom, there. Okay, so it wanted to show us. Maybe that's why it just slowed down the video. They slowed it down just so that we could really focus in here. These are the last few images. Look, that rock is no more. That's the last image of that rock. See ya. And so That is the real picture. That is real Didymus. That is real Dimorphos. That is cool. Wow, that's interesting. So there we go. That happened when? On September 26, 2022. Okay, so our graph, they're talking about here, our graph shows an orbital period decrease of a few minutes, matching initial predictions, but not the results. Okay, so the initial predictions were different than the results. More detailed analysis in the future Hera mission, which will study the aftermath. Let's get this going. Let's get this moving. Okay, we're gonna slow it down a little bit so we don't go in too fast, but now we're moving in, okay? And as we're getting closer, I'm gonna finish reading this. So more detailed analysis in the future Hera mission, which will study the aftermath of DART impact, will shed light on what caused the unexpectedly large decrease. So they were expecting a smaller decrease. They weren't expecting 32 minutes change, but they got 32 minutes change, which I think is a good result, right? Like they want to be able to affect it more in case they have to do this in real life to an asteroid. I mean, they did it in real life, but if they have to do it in a scenario where an asteroid is coming at Earth, they want to affect the trajectory as much as possible. So I would say 32 minutes is a good result. No asteroids, including Didymus or Dimorphos, currently present a threat to Earth. Okay, that's good. So here we go. We're getting in close here, and boom, let's see what happens. Okay, we have a little crater there. So that happened, and we see up here in the graph the time changing. I don't really understand these numbers, pressure versus radius, but this looks like minutes. So this is what they were expecting. Maybe, don't quote me on this, I'm not a scientist, but if you want to, you can leave the real answer in the comment. But it looks like they were predicting 5-minute change, but what they got was 32 minutes, which is awesome, I think. That sounds like a successful mission. Okay, so let's restart this. Okay, we hit restart, and we're gonna hit play. We're get a little closer to DART. We're gonna click on DART, which means we're gonna follow DART, and here we go. This is about, I think it's pretty close to real time, and here's the explosion in real time, boom. Okay, so let's restart one more time. I got an idea. Let's be on the surface of Dimorphos when this happens. Let's look back from the surface. Let's get real close and then we'll pause it on Dimorphos. So let's zoom in here to Dimorphos. We click on Dimorphos, and if in Universe Sandbox, we hit the letter C, what it does is it flips us around on the surface of what we clicked on. And here we go. Here is DART. And let's slow it down just a tad. Okay, and then we'll hit play. And we'll see, okay, here comes DART. DART's coming in hot. Okay, DART was released. If someone was on this, Dimorphos, like, what in the world, where did this come from? This does not look natural. This looks man-made. Yeah, Earth shot it at, yeah, sorry. But here we go. So, looking from here, and boom, we have explosions. We have fragments, and now they've disappeared. Okay, so that's interesting. So we hit C to come off it, and we have our little crater there. And I wanna do this one more time, and I wanna see, here's what I wanna look at. If we can, because we don't know when it was launched, we'll have to look that up. Let's try to figure out when it was launched by backtracking, by putting it in reverse time and seeing when, let's see DART being released from Earth. Is that something that we can do? So okay, so we're gonna restart. All right, and now we're gonna reverse time, hit play. So let's speed up time because we need them to pass orbits. There we go, now we're cruising. Now we're cruising. Okay, so at some point, and it looks like there's some weird orbit things happening. So the settings aren't real life, but we gotta get pretty close. Let's see when they pass, when they cross. Okay, so like Mercury's doing a weird thing. The sun's going off on its own, so this is weird. But let's see if we can see when they pass, and when they pass, let's find the date. So we're at April 2022. Let's speed up just a tad, and we'll pause it when they cross. They're about ready to cross. Right about, here they come, here they come, here they come, here they come, and cross, boom. Okay, what is this? November 22nd, 2021. All right, so let's figure it out. Let's look this up, okay.
A little longer than a few minutes later.
Oh, check this out. Okay, mission overview, DART, okay. Look at this. Launched November 23rd, 2021. Okay, we were so close. Okay, so that was pretty accurate. So it took about 10 months for it to travel to where it needed to go, to Dimorphos, and collide with Dimorphos. November 23rd, 2021, and right in our simulation, we got November 22nd. Okay, that's pretty close. Yeah, and maybe I stopped it too late. Yes. So, boom. Yeah, well, I stopped it too late. So that's pretty accurate. So now going back to normal time, we can see then how it happened. We can see the whole travel from Earth. Earth is here, DART is here, coming off DART. We're looking for down here. September 26th is when it collided. We'll speed up time just a little. And we see, here we go. Didymus right up here, coming into line with DART. And this is when it all happened. And this is how it all happened. Okay, boom, right there. Wow, boom, that's amazing. That's cool. That 10 months earlier, we can shoot something off the surface of the Earth and have it collide exactly with a moonlet. Okay, something small, a moonlet. And what Earth is doing here, the scientists, the people who have decided and we've put in charge, or someone's put in charge to make these decisions for Earth, they've decided to take preventative measures, okay? And prevention, if you've heard of the quote, an ounce of prevention is worth a pound of cure. Okay, if you think about like a sickness, okay? If you're doing preventative work, which means getting regular checkups, then we can see then if something pops up that's like a little nerve-wracking, we can test it and find out well in advance before something spreads, right? So prevention is worth an ounce of prevention is worth a pound of cure. If it's too late, if we haven't done tests and we don't catch something early, then we're doing a lot. We're doing a lot with limited time. We're trying to catch up and do that sort of thing. So what Earth is doing is an ounce of prevention, which Earth is not threatened right now, but they are taking preventative measures and trying something out on kind of like a small moon. And like we saw before, 2.5 tons of energy is actually not that much. It's not that much damage. But we got 32 minutes change in the orbit, which is pretty awesome. And so this small little thing early on is going to help Earth not be in a place where, oh no, like there's something coming to destroy Earth. We have to hurry up and figure this out before it gets here. No, we've started some tests, some experiments before it gets too late. It becomes too late. So my question is for you, how can that be true in your own life? If something may happen in your life where you're surprised, or something bad, like what could you have done early in advance to put up a system, to start experimenting, maybe including people in your own life that help keep you accountable or want the best for you, so that when something hard comes, you're not out on a limb by yourself. You're not alone. You're not isolated. No, you have a team of support, people in your life, tools that you've developed that are going to help you, be ready for what's to come. Because inevitably, a lot of you are young. Some of you might consider me young. I don't, I'm getting up there. A lot of you, my guess is a little bit younger than me. But as we get older, inevitably more things happen, right? More variables are at play. Our bodies begin to change and things stop working as well as they used to. Our heart begins to shut down. I mean, we are continually, our body from day one, from birth, is dying. Right? It's becoming more old, more rickety. There's more chances for things to go wrong as time goes on. And so what we're trying to do with prevention is be proactive, thinking ahead, not letting time get the best of us, being surprised that, it's too late in my life to do something. It's not. Another good example of is investing. So if you started investing really young, it only took then, because of compound interest and time's on your side, that the amount that you put away to invest, you don't need as much to get to this bigger amount, this goal amount by the time you retire. Whereas if you're 10 years before retirement, 5 years before retirement, you're needing to put a lot more away to get to that same goal. And that is how an ounce of prevention is worth a pound of cure. And maybe that's what it is for you. Maybe you need to start investing or putting your money away or, saving. That's maybe more of a, not shallow, but not as emotionally scary or draining as cancer. And so what has been good for me, and hard for me, but good for me, is thinking ahead and planning for the different outcomes that could come in my life. And they will come, different outcomes, and good things and bad things. But especially planning for the bad things, the worst case scenarios, which Earth is doing in this with this experiment. Planning the worst case scenario, we can test on a not worst case scenario. That is prevention. That is thinking ahead. That is planning. And so what in your life is that applicable to? We're gonna restart the simulation one more time. And we're gonna watch out how DART finds its way again to Dimorphos. We're gonna slow it down a little bit. And as we do that, as we watch this happen and listen to some calming music as we do, think about in what ways could you think about prevention? In what ways could you be proactive? In what ways can you experiment and plan for the future? Think of the worst case scenarios, but you know what? Being able to think of the worst case scenarios becomes a blessing. It's a curse when it's too late, but it becomes a blessing when we think ahead. So think ahead, and let's think about that as we watch this happen one more time. Deep breaths with some soft music. And there we have it. If this is your first time here, I want to hear about it. And I'm interested that if this is your first time watching the video on my channel, like how depressing was it? To talk about death and explosion and cancer. But I hope you gained something from this. That's the ultimate goal here, is to not just let our life happen and not have a reaction, but to tune in and be present with our life, to be engaged with our life, to take part in it. And the best way, one of the best ways to do that is to think ahead. You know, we talk about a lot about thinking about who we want to become and that determining our trajectory. And this is in a similar vein where we are planning the worst case scenarios, but the worst case scenarios become blessings when we take preventative measures. So that's what today is about. Take a preventative measure, try it out, whatever that looks like for you. And I bet you'll feel good that you did, especially when the worst case scenario looks like it might be on its way to you. You're already ready for it. So anyway, I hope that was important to you. Leave a like, leave a comment, subscribe for more, and I would like to see you again. Until next time, keep it chill. Bye-bye.